Hi, good day to you all. In this video lecture session, you will learn the basic procedure for developing CNC part programming for a simple component having straight turning operation. This is Dr. Suresh Babu from the Department of Mechanical and Industrial Engineering, National University of Science and Technology, Sultanate of Oman. CNC part programming is a sequence of instructions which is fed into the machine which can produce the part using CNC control system. The steps involved in writing a CNC program are given here. There are 7 major steps or 7 fundamental steps which are used to create or to develop a CNC part programming. The first and foremost is that the customer drawing or the blueprint is to be studied thoroughly, wherein the shape and dimensions of the given object or the given component is studied. Then, after studying, a machining plan is arrived at, followed by the chucking area is decided, which is either chucked by using a soft jaw chuck or a hard jaw chuck. Later, the tooling selection is based on the surface finish which is required for the given component. We can select roughing tool and finishing tool based on the requirement. The next step goes with selection of the cutting parameters, wherein the speed, feed and depth of cut is appropriately selected, which achieves proper or optimal cutting conditions, finally leads to the surface finish in a better way. With knowing all these 5 items, we can just start writing the CNC programming, and later this CNC program can be punched into the CNC machine control system, and the machining operation is carried out to produce the given part. The component for which CNC part programming is to be developed is shown in this slide. The material for the workpiece is given to be mild steel with a cutting velocity of 120 meter per minute, and the workpiece diameter is given to be 40 millimeter by 100 millimeter. Now let us understand the blueprint which is given. The study of the blueprint reveals that the overall size is 40 millimeter by 100 millimeter length overall, and this 40 millimeter is to be machined to 35 millimeter as a step for a length of 40 mm. So it has a step machined for 35 by 40 length. The total depth of cut is 2.5 millimeter. This total depth of cut is achieved by subtracting 40 minus 35 over 2 for one side, which is equal to 5 by 2 equals 2.5 mm per side. The chucking is to be carried out on this area, and this can be done at 40 by 60 length. 40 by 60 length. So this is the understanding of the blueprint, and now we shall proceed to the next step. As indicated earlier, the cutting parameters which are to be decided before proceeding to the CNC programming are speed, feed and depth of cut. The speed can be decided by the formula the cutting velocity Vc equals pi dn over 1000, where d is the diameter of the workpiece, which is the major diameter or maximum diameter. N is the spindle speed, which is given in the unit of RPM, Vc is the cutting velocity. Cutting velocity is given to be 120 meters per minute. 120 meters per minute. 120 meters per minute. So now substituting the values which is known, we know the cutting velocity of mild steel which is given in the problem to be 120 meter per minute, and pi d is the maximum diameter 40. So 40 is substituted here, pi value, and n is the unknown which we are going to calculate, divided by 1000. This is a unit conversion from meter to millimeter. So n will be equal to 120 multiplied by 1000 divided by pi by 40. So the answer will be 956 revolutions per minute, RPM. So 956 RPM is the spindle speed maximum which we can have for this workpiece to machine the 35 millimeter diameter. Now let us move on to the next cutting parameter, namely the depth of cut. So depth of cut can be calculated from the given geometry. 40 is the maximum diameter and 35 is to be machined for a length of 40 millimeter. So depth of cut per side is given by maximum diameter minus minimum diameter divided by 2, since it is per side. So maximum diameter 40 and the machined diameter is 35 divided by 2, which gives you 5 over 2, 2.5 millimeter per side is the depth of cut, which need to be removed from the workpiece to get the shape of the object. So in this, how do we plan the roughing cut, number of roughing cut and number of finishing cut? Since 2.5 millimeter per side is there, number of rough cut can be taken to be 1 millimeter each. Two cuts, if it is planned as two cuts with 1 millimeter each, then it will be 2 millimeter. Then one finishing cut of 0.5 millimeter, one finishing cut of 0.5 millimeter. If it is added, you get an answer of 2.5 millimeter per side. So on overall, it will be removing 5 millimeter diameter. So 40 minus 5 will get you 35 millimeter as the output diameter. So this is how depth of cut and the roughing and finishing cut are calculated. So one important thing is while calculating the roughing and finishing cut, take care of machine capacity. Machine capability. If the machine is not able to cut 1 millimeter, we cannot take a rough cut with 1 millimeter. You have to reduce the depth of cut. So if machine is capable of making more cut 2 millimeter, then accordingly we can plan one cut to be with 2 millimeter and another cut, finishing cut with 0.5 millimeter. It all depends upon the machine capability. So you have to take care while designing the roughing and finishing cuts, the machine capacity or machine capability. Now the last cutting parameter which we are going to see is the feed rate. Feed rate is based on one of the important parameter called surface finish. So mostly roughing cuts are given little higher feed and finishing cuts are given little lower feed rate. So normally for rough cut we can order 0.15 to 0 mm per revolution, and for finish cut we can order 0.1 mm per revolution. This is the case for lathe machine. When it comes to the milling machine, the category depends upon the cutter or the number of cutting edges or number of cutting teeth which are used in the cutter. So, in overall, the feed rate basically depends upon the requirement of the surface finish which is given in the drawing. So, to summarize, rough cut you can use 0.15 to 0.2 mm per revolution, and finish cut you can go with 0.1 mm per revolution. The program structure, a CNC program structure, has been earlier discussed in some other lecture session, but however, to the concept, to understand the concept, I will repeat it in this place once again as a summary. So every program will have a program start with a program number, then followed by you will cancel the tool and tool offset, then followed by you can call a new tool for the machining process with the offset which is preset in the machine tool, then spindle switch on, coolant on if required. If the machining needs coolant, then you can switch on the coolant using coolant command M07. Safe position of the tool, park the position from the home tool turret reference position, park the tool to safe position, then start machining the given object. Then once the object machining is completed, send the tool to the safe position, switch off the coolant, spindle switch off, move the tool to safe position, and end of the program. So this is how the sequence works out. So you will start the program, cancel the tool offset, then call the tool, spindle on, coolant on, safe position of the tool, machining operation, then coolant off, spindle off, and then move the tool to safe position and end the program.